Okay, so you already know from next week, no class meeting for Tech 1 on Monday. And the Tech 2 will be on Monday and Tuesday. The thing is, we need more thing to do for the Tech 2. And that will be applied until the end of the spring semester. That means June 14th. Next week, I will be let you know what day will be the final for electronic spring 2021. Okay? Any question? Anything? Okay, so today, basically, I try to review on the bipolar transistor amplifier. That's a last thing for you guys, okay? You understand we get the two measure for the transistor. First is the bipolar transistor, NPN, PNP. And the second one will be JFET, okay? Will be N channel and a P channel. They will be similar, okay? That means either for bipolar or JFET, first part of the circuitry will be the DC bias. You need the DC power for the transistor to be working, okay? Then you're using the transistor for the amplifier. In the bipolar, you get a common emitter, common collector, and common base. Also in the JFET, you can get a common source, common drain, and common gate. You can see they're very similar, okay? And this time, I try to go over for you and adding a little more thing on the bipolar transistor. So you understand for the capacitor, okay, to say a coupling capacitor, okay? Try to understand, and anything you not quite, go ahead and question, okay? You can see that this is a source here, okay? And this is a load in here. You get a capacitor right here. So in order for good coupling, that means the side wave coming in, side wave coming out. Then they say, okay, I want Xc have to be less than 0.1 of the resistor value. You understand Xc, right? 1 over 2 pi at Rc, okay? And this is given to you when the capacitor is short for AC. They just lay the wire, okay? And also for this one, for DC, capacitor will be open. That means no current can be flowing from the source to the resistor, okay? And for AC analysis, capacitor is shorted, and at DC analysis, capacitor is open. That's what you need to memorize, okay? And if you want to learn more, that's an engineering level. If you want to perform for the amplifier analysis, that means for the AC signal, then you have to perform completely for the DC analysis. That means on off the calculation. for the DC must be done. Then they say source on coupling or bypass capacitor. Now you know how to sort it. Visualize on DC supply voltage at AC ground. So you don't see any DC power supply in the AC module. Replace the transistor by either pi or T module. Draw the AC equivalent circuit. That's what you need to do. Okay? And in here, one of the module here, that means instead you draw the DC here, transistor, okay, NPN. When you convert into the DC, AC, then they will be look like that one, okay? This substitute for the other one. And you can see on the DC, between the base and the ammeter, you get this is the diode, okay? However, on the AC, diode turn out to be the resistance R prime E. That means internal resistance from the base to the ammeter. And the value will be calculated by this formula here. Okay, 25 millivolt divided to the DC current IE. Okay, any question? Now, when we're talking about the gain, you get the input and you get the output. Okay, the gain basically definition that's the ratio between V out over V in, or I out over I in, or P out over P in, depending on what is the gain for voltage or for the current or for the power. That's a very basic definition. Okay, now the first thing they're talking about common ammeter amplifier. Okay, when you're looking into this circuitry, your job will be recognize what the type of the circuitry. They can be common ammeter, they can be common collector, or common base. Okay, so common ammeter, input applied to the base, output from the collector. Okay, and that is the first thing you need to know. Second thing, what is a C1, a C2, and a C3? C1 will be DC blocking or AC coupling. That means they allow the sine wave from the input go to the base. However, no DC from the input can go to the base. Same thing for C2, DC blocking, AC coupling. That means at the collector, you can get the two different types of the signal. One will be DC bias, and another one will be sine wave. Okay? But when you go into the load here, like the speaker, they don't want any DC from the collector go to the speaker. So that's why that will be blocking that DC. And finally, you get a capacitor C3. The name will be bypass capacitor. What capacitor bypass? They will be bypass the resistor RE. That's only telling you for the AC signal. If you measure at the ammeter, you're supposed to get a 0 volt. The thing is, capacitor will be shorted. AC current will be go to the short to the ground. They not go to RE. Okay, so that is for the common emitter. And this is very good for the technician. When you're looking into this circuitry, they're telling you everything on the common emitter. You get a sideway here, and they get the same sideway go to the base. Okay? However, you don't have any sideway at the emitter, the thing that they bypass. And also at the collector here, you can get a 1 DC bias, 6 volt, 0.04 volt. And also the sideway. But this sideway compared to the input, they will be 180 degrees out of phase. Okay? And when they go to the load, they don't have any more DC 6.04 volt. This capacitor will be blocked. So when you're looking into the common emitter, I recommend you try memorize on up those things, okay? Like if you want to measure at the output, at the collector here, if you want to measure the sine wave, what your oscilloscope is supposed to set for coupling. I repeat the question. You're using the scope to measure the sine wave at the collector. What your oscilloscope will be set up for AC coupling or DC coupling?
AC.
Perfect. When you set it up for AC coupling, they not display DC. So you can see they will be look like here, 0. Okay. If you set for the DC coupling, they display both. Okay. One will be 6.04 volt and also this sideway. So maybe you cannot see this sideway or cannot measure. The thing is they will be inside 6.04 volt DC. That's too big. Okay. Especially at this point, the bay hole. So the bay here, you get a 1.8 volt DC. However, AC, they will be 100 microvolt. So this signal will be too small compared to 1.8 volt DC. So if you not set to the AC coupling, you cannot measure the sine wave. Okay? Yeah, go ahead.
I was laughing, excuse me. Somebody was snoring.
You need to mute the mic. Somebody fell asleep and started snoring.
Oh. Okay, just a minute. Okay, so basically, this we already get everything done. Okay, that means when you're converting into the AC and R1, R2 parallel, and also you can get the resistor from the base to the emitter, R, right, E. Okay, now if you want to calculate the input impedance, that means you're looking from V in into the amplifier. See how many resistors. That's what they're talking about, input impedance. And if you want to looking for the output impedance, That means you're looking from the output here, go to the amplifier. In this case, you can get a RC as a collector in parallel with L. So they can say RC small lowercase for AC. Sometimes we're using G out, output impedance. They will be RC parallel RL. And if you want to calculate the gain, they already given to you here. Okay, you take RC divide R prime E. Okay, and now they given you the sideway 10 millivolt here. And you can see the output will be a bigger sideway, but they will be 180 degrees off phase. So they given you the beta DC 150 and the beta for AC 160. If they not given to AC, you can using all the same beta. Okay.
Hey, Mr. Pham, can you go back to that other one? One more. Yeah, right here. The little RC, that's the
Yeah.
big RC in parallel with the RL. And I noticed up top, you can use the little RC divided by the R prime E to get the gain. And okay, now the R prime E, what's the deal on that? Is that in parallel with R1, R2?
That doesn't matter. That is, they have to calculate the gain in order to come up with this formula. Okay. However, R prime E, that will be an internal resistance.
Oh, also too, if maybe I'm answering my own question. So R1 and R2 are probably pretty big, at least a lot bigger than R prime E. So that can be, those can be ignored. Is that correct or what?
You have to do calculation to come up with this formula.
Mm-hmm.
Okay.
Mm-hmm.
I believe we can get it somewhere in the handout. Okay.
I guess what I was asking you is R prime E is so small that when you're doing the gain, that R1 and R2 wouldn't apply. In other words, R prime E is really, really small compared to, and so is RC compared to those other values.
I don't think so. We'll see where we do calculation.
Okay.
Okay.
Thank you.
On this circuitry here, we already done before. That means at least minimum thing you're able to do it without looking into anything else. Like they will calculate the VB right here, VE right here, current IE, current IB, current IC, and VC, then VCE. Okay, that means everything here you must know how to do calculation right away. Okay, and
Hey, Mr. Pham, and just one other thing. No, you're fine. You're fine. Just one other thing. Did you say if you have an AC beta and a DC beta, which one should we use?
if you calculate for the DC, you're using beta DC, right?
Okay.
If you calculate the AC, normally you're using beta AC. However, what I'm saying is if they're not giving you beta AC, then you can using beta DC.
Okay. Thank you. Thank you.
They're not much different.
Mr. Pham,
Yes, sir.
for beta, isn't the percentage of how that component is going to work run by DC only?
No, you have to using also inside of the AC, right?
Correct.
Like,
But
like you see, they say calculator are in. They're using the beta time R prime E. If they
But
don't even do beta AC, then you can using a beta DC. To me, that's not a big deal. The thing that they're not quite different. They almost low, the same.
what I meant was if the component didn't have AC, it would strictly be just a DC powered component. So you have like a DC circuit and then you have an AC DC circuit. So the majority of the component, like any circuit in general, DC by percentage is what is going to power that component. I understand AC is going to be for a different circuit, but I'm just comparing the usage of DC when beta is referenced.
Yeah, when you're doing any calculation for DC, then you're supposed to be using a beta for DC. That's a number given for 8 different types of the transistor. You can see that if you get a current IB, you can calculate the current IC, and that basically depends on the beta. And the beta will be built up with the different transistor. They're not the same.
Hey, Mr. Pham, that RC right there, the fifth line down, that's supposed to be a little RC, right?
Which one?
In black, the fifth line down.
Okay. RC is supposed to be R small c.
Yeah, so where it says voltage gain equal big R and then little c divided by R prime E, the big R should actually be a little r, right?
Right.
Okay, thank you.
Okay, the thing is sometimes the book, they get confusing. Okay. Sometimes they're using a small RC. Sometimes they're using a big R but a small c. Okay.
Okay,
It's both bigger. Upper R and C, they will be DC. Okay.
okay, I got you.
And now for the AC, what they want R prime E. We already know. They know how to calculate the R in base and the R in total. Okay. And RC, in here I have to put the output resistance or Z out. Make more clear. Okay. AV, that means the voltage gain. And also they want to calculate the V out. All of those calculations supposed to be no problem, okay, with the guy up to this point. Okay, so this one, just for the circuitry, CEMD5 with no bypass. You don't see any bypass here. I delete that. Okay, so when you draw for the AC, then you can see at the meter here, you get the current, you get the resistance go into the meter. That will be internal resistance, R prime E. And now you will get another resistance, that means RE. Okay? So that will be telling you the voltage from the base to the ground, they will be adding R prime E plus R big E. Also, I want to mention to you, when they don't have what happens if they don't have a bypass capacitor? What happens to the amplifier?
The AC signal can't go through, right, or whatever?
No. Now that for sure they don't have a bypass, right?
Right, the bypass was to let the AC through, but not the DC.
Yeah. But they not bypass now. What happened to
The gain is reduced.
can you repeat?
The gain is reduced.
The gain will be reduced.
Yes, sir.
Oh, sure. That's what I want you to memorize. Okay. When you get a bypass, the gain will be increased. However, no bypass, the gain will be going down. Okay. So basically, they want to get the IC value. So anyone can get it, that answer for me. Try to see without looking anything, can you get on of the A, B, C, D, E, F? Quickly telling me.
Which circuit that other?
That's the circuit here, right?
Oh, that one right there. Okay.
Oh man, how come? There you go here. Shh. That they want to calculate with no bypass. R prime E, they will be the same. But the R in to the base will be different. And R in total also will be different. G out, RC will be no different. However, the voltage gain guarantee they will be different. The thing is the gain will be going down. If you can do it quick, maybe next few more years, I can see you can be engineering. Okay, so the fourth one will be 22 ohm. If you're doing it right. Who get the R in base for me? Okay, if it's not, I can give you the answer. Okay, this is first thing is the answer for the DC calculation. Okay, that's the value for DC calculation. And now for the AC calculation, I given you the formula. R in base equal beta AC times R prime E plus R E1. And if you want to calculate the R in total, that will be R1 parallel R2 parallel with R in base. RC output impedance will be okay. R big C parallel RL. The gain will be RC, that means G out, divide R prime E plus RE1. Oh, okay. That one I have a no answer. Let's see. With no bypass. I give
Hey,
you
Mr. Pham, can you go over this whole thing on your iPad so we can have at least one example of how to do this?
which one?
The one you got up here right now.
No bypass, right?
Yeah. Can we do the whole thing? That way we'll have a good example
Okay. Let's see.
on your iPad.
Okay. Just a minute. Okay. First thing you understand R prime E. No big deal.
Right, that's 25 millivolts over IE.
22 millivolts. Now, try to understand R in base. If you're looking into this circuitry here, if you convert it into the AC, then you can get the R1 here, right?
Mhm.
R2. And in here, you can get the RE, right? You can get the resistor RE here. Prime E. Okay, now, what is the input resistance of the transistor? That means you're looking from here into the transistor. Try to say, okay, how many resistance you get. That's what they call R in base. So that means you're looking into here. R in base. Can you tell me how many resistance you get?
Three.
That means you have to look in from here.
I think 582 ohms.
So you got R1 in parallel with R2.
No. This is not count. If you're looking from here, you're not looking from here. That are in total. That means everything. Right now, I'm talking about in base. That means you're looking into the base from here.
Yes, it is 582 ohms.
No, we don't, the value, we need to know which resistance. Oh, so it's R2 and then it's
Yeah.
RE.
No.
Yeah, plus RE.
I said you don't care R1, R2. The thing is you look from here.
Oh, I see what you're saying. So it's, you're looking at RE, little RE plus big RE.
Yes, right.
Done.
What did you say, Mr. Pham?
I said still not done. You can say R prime E
Right,
and R big E,
right.
but I said not done yet. Who else?
RL.
IL is not related into the input resistance.
Okay.
Okay, that's the output resistance. Okay. If you're looking from the base,
Divided by RC.
nothing to do with RC, right? That's the output impedance, not input impedance. If you're looking into the base, how many resistance you can see? And Mr. Smith told me you see R prime E, okay, R big E, okay. However, it's not complete yet. Who else?
So you, is it
Z.
like a beta or something involved with that? 'Cause you said,
Somehow,
The only thing would be beta AC.
but right now I just talking about basically how many resistance you can see when you look into the base.
I
Five.
can see two.
I think that's it because we don't have the capacitor here.
Okay, now maybe I have to tell you. You have to see from the base to the route. And that also you can get the resistance. They call RB. What is the RB?
R base.
R base, correct. But that will be telling you the resistance measured from the base to the route. You see that? They not show up. But from the base to the route, you also make sure you get the resistance. That's what they call RB.
Okay, so now, Mr. Pham, so is that like added on or is that in,
Now,
Or-
if you draw it, then you can say RB in parallel with R prime E and R big E, right?
Okay.
That means they the same from the base to the round.
So what you're saying then, it's little r, little b in parallel with R prime E in parallel with RE.
Now, R prime E and RE in series.
Oh, little r, little b is in parallel with those other two.
Okay, so let's see. That will be a resistance from base to round. And now if you want to calculate the R in base, that means every resistor at the base, they will be RB parallel with R prime E plus R big E. You get that?
Okay, so Rn base equal R. Okay, yeah. Got it.
So basically you can get this resistance here parallel with combination here. If you're looking into the base.
Okay.
Okay. So now, I don't know, I still memorize. However, who tell me, how do we calculate the RB?
base AC multiplied by R prime E.
RB means the resistance from the base to the round. Using the Ohm law, what RB equal? VB divide right?
Right. Yeah, it's Ohm's law.
That's Ohm law. VB. So what VB equal?
V in.
Come on, who care? I'm talking about VB right here. By definition, if I given you the meter, I tell you, okay, measure for me the voltage.
R2 VCC.
Okay, if I given you the meter, I asking you to measure the voltage at the base. You connect positive to the base. Where is the negative?
Ground.
Wow. VB means the voltage from the base to the ground. Okay.
So use a voltage divider.
Now, nothing to do with the voltage divider up there. I want you not take anything into this calculation. The thing is, you want looking into here, not related into R1, R2. VB will be equal, let's see, voltage from the bay to the route. Okay, so they will be equal, the voltage go to R prime E, plus the voltage the current go to R big E. So they can be equal IE times R prime E plus R E 1. That means the voltage from the bay, okay, go to the resistor here. And that will be given divide to IB. And now, okay, let's see. Sorry, I have to write it way. RB, VB, IB. Okay, so now I can get RB equal IE. You know IE equal what? 1 plus beta time IB. Everything will be time R prime E plus RE1. Everything divide IB. So the IB cancel. Okay? So basically the formula RB equal 1 plus beta time R prime E plus RE1. And some different book, they don't care about 1 plus beta. They just using beta. Time R prime E plus RE1. That will be RB. Now, if you're looking the one I given to you, okay, this is the R in bay here, okay, beta time R prime E plus RE1, okay, so that will be calculated for you R in bay here, okay, they will be beta time R prime E plus RE1. Okay.
Mr. Frank, can you show RE1 on the circuit? RE1.
IE here. IE.
Oh, okay.
Okay. They don't have a IE1.
Oh, okay.
That's IE. Okay.
Yeah.
that you understand that really engineering, they have to go on not the very detailed calculation. But not basically, we are the technician. We are testing. We not design anything. Okay? When you're testing, only thing you're using the test equipment to measure to see you get a right value or wrong value. Then you try to fix the circuitry. You don't care how they get that value. Engineering telling you that's what they wanted. Okay, now if you want calculator R in, I'm not doing calculation, but I can tell you. Okay, in this case, if you want calculate the
Originally, you
Oh.
was trying to get VB.
we don't need to calculate a VB. If they want to asking you R in base, then you take a beta AC times R prime E plus RE. Sorry, not R you want. My question is, now they want to get a total impedance, okay? If you're looking that one, I check that out. Now, they want to looking Z in total. Okay, then now you telling me how many resistance in parallel.
Three, R1, R2, and R in base.
Perfect. That means you get the right one. R1 parallel with R2, okay, and parallel with R in base. So I given you the formula. R1 parallel R2 parallel R in base. If you get on those values, you can do your calculation. Make sure you're able to follow it, okay? This is the last chance we can give a review for you. Sometimes you go only one time, you cannot get really understanding. A second time, giving you a better picture.
Hey, Mr. Pham, so for letter B, R in base and little RB is the same thing, correct?
Yeah,
They're the same.
no. R base, R in base.
R in base
Yeah,
and little RB.
I think they will be the same.
Yeah, that's,
The resistance from the base to the route.
yeah, go back up and then you'll see what I'm saying.
Yeah. Right?
Right, so the little RB is the same as R in base.
Now, try to see the difference. RB, that means the resistance from the base to the route. That's RB.
Mm-hmm.
However, R in base you're looking into here, then you can say this guy here parallel with R prime E series with that guy. You see that?
Okay,
That is the difference.
okay,
Okay.
all right.
So GL we can easy to recognize, right? As big C parallel with L. Okay. That is the gain. And VL equal AV time V8. Okay. Now I just go over that one and make sure you try to doing on the calculation we needed. Next meeting, we'll try to see who can get everything we wanted. On this circuitry, they call a Swameped amplifier. That means you can see the difference is they get a two resistor here, RE1 and RE2. And the capacitor C2, they bypass RE2. So in the circuitry, you still get RE1. So if you measure the voltage AC at the ammeter here, you still get the AC voltage. The thing is no bypass for RE1. However, if you measure at this point here, then you get no AC. The thing is they bypass by C2. That is the first difference for the Swameped amplifier. This one will be the same thing, nothing. But this is a problem right here. When you're doing your calculation, AV for the amplifiers, what the AV equal? Voltage gain.
V out over VN.
AV equal what?
V out over VN.
You say it's right?
Right.
No. That's not.
It's always been that way, hasn't it?
The thing is you didn't say that guy.
I see.
You see that?
Yeah,
Okay, basically, when you say AV equals V out over V in, that must be the difference they call overall gain. Gain for the complete amplifier. However, for the CE amplifier, what the gain equal? They will be equal V out. However, divide to V B. The gain up to here only, not up to here. Okay, not count up to the input. So everything we did in the past, that means V out divide to VB. However, when if you don't have this resistor here, VB and V in will be the same. But it not happen for this circuitry. The thing is you get the resistance of the source here, 600 ohm.
Mr. Pham,
So I can give you a little help. After you get the gain right here, and the gain, everything, they will be after using the voltage divider. So you can see, after you calculate the R in, so basically in here, you can get the impedance right here. That will be R in total. Okay, so now if you want to calculate the gain right here, so basically I can draw this way, you can see 600 ohm here. So you have to using the voltage divider, okay, between 600 ohm and R in order to get the gain for the total. Next week, then I will be doing calculation for you, okay? However, this is the one, okay, the calculation I can give you up to this time. That means for DC calculation, we already did answer. AC calculation, I just given you the formula, and you do your calculation. Okay, and anyway, make sure you understand you don't have a class on next Monday for Tech 1. I have to take Tech 2 on Monday and Tuesday. So try the best. You're able to do your AC calculation for the Swameped amplifier. See how much you understand. Everything you do, you have to try to understand it. Okay, that will be better. Okay, so if it's not any question, then make sure you download your quiz report 21 we do take the quiz now.
Can you go back one page, Mr. Brown?
Okay, no question, right?
Can you go back one page, Mr. Fan, please?
Oh, one page. Here.
Thank you. Thank you.
You're welcome. So that's why normally you can see on the quiz, I'm not asking you too much detail. We want you to get a job. Okay? After you get a certificate, only thing we need, we'll be telling you what you need to understand to pass the interview. Okay, let's see, 21. 2021. So from next week, you get only one quiz on Wednesday. Is it the time run out?
Let me see. Yes, it looked like it's time.
Okay, you got the answer of number 8.
That's my mistake. That's your bonus. Okay, so upload it and good night.
That was fun.
Good night.
Good night, everyone.
Now, Mr. Pham.
Okay, we'll see you next week. Almost end on this semester. So far we're doing very good.